Let's solve this managerial economics question together. So we have a question on economic optimization. So I'm going to read a question. So the question says that a company has the following total revenue and cost relation. So you have the total revenue to be 60 kil minus 0.005 kil squared, and the total cost to be 8,000 minus 5 kil plus 0.005 kil squared. Then the A says that we should determine the quantity and price that maximize total revenue. All right, so now let's find the quantity and price that would maximize the firm's total revenue. So now, anytime it comes to optimization, once you're asked to find the maximum price or the quantity or the price that will maximize anything, whether it's profit, total revenue, or anything, know that you're about to differentiate and equate to zero. So whatever function you have, you differentiate it and equate it to zero. So now we're asked for the quantity and price that will maximize the total revenue. So now we are going to we have our total revenue to be 60 kil minus 0.05 kil squared. So this is our total revenue. So now to find the maximum, we have to differentiate it. So you are going to get the TR over the kil is equal to, so now let's start at differentiation. 60 kil, we are differentiating with respect to kil. When you differentiate 60 kil, you should get 60. The kil would vanish. Then when you differentiate negative 0.05 kil squared, the 2 will multiply the negative 0.05. So you should be getting 0.01, right? Then you bring your kil. The exponent you reduce by 1 and to vanish. It gets, because anything exponent 1 is the same thing. So after you differentiated it, then you equate it to 0. Please, a lot of people forget to equate it to 0. Don't forget, always equate it to 0. So now if you are equating 60 minus 0.01 kil to 0, we can let the 0.01 kil or the negative 0.01 kil cross the equal to sign. So we are going to get our 60 to be equal to positive, since it's crossing the equal to sign, so positive 0.01 kil. Then divide both sides by 0.01 to let kil stand alone. So this will cancel this. Then our kil should be equal to 60 over 0.01 should give us 6,000. So the quantity that will maximize the firm's sales revenue or the total revenue should be 6,000 units. You get it? So that's for the quantity. But then they said the price and the quantity, or the quantity and the price. So you now have to find for the price. But we already know that total revenue is price times quantity. I hope you've not forgotten that. The formula for total revenue is price times quantity. So now we need to find for the price. So in finding for the price, first, if the total revenue is price times quantity, and our total revenue is 60 kil minus 0.05 kil squared. This is our total revenue. We know that it is equal to price times quantity. I've not done anything. We already know that this is the total revenue. I just brought it down and I equated it to the P times the Q. You get it? So now we are interested in finding the price since we've already found the quantity. So we divide both sides by the quantity so that this and this will cancel. They want to be left with price. So I also divide here by quantity. So if I'm dividing here by the quantity, remember that this 60 kil is divided. Remember that it's 60 kil over kil, then negative 0.05 kil square over kil as well. The kil is affecting both of them. So what is 60 kil over kil? The kil will cancel out. So we are going to be left with 60, right? Then negative 0.05 kil square over kil. This kil will cancel one of this kil. So to be left with just 1 kil. You get it? So you are going to get negative 0.05 kil is equal to P. This kil has already cancelled this one. You get it? So now we know that 60 minus 0.05 kil is equal to P. But you also know that our kil is 6,000. So you just substitute it into it. So now 60 minus 0.05 times kil, which is what, 6,000, should be equal to P. Do you get it? We can solve all this on the calculator. So 60 minus 0.05 times 6,000. And that should give us 30, right? So our P is 30. You get it? So our P is 30. All this will give us 30. So the price that will maximize the firm's total revenue is 30 cedis. And the quantity is 6,000 units. I hope you get it. All right. Now let's move on to the B. The B says that you should calculate the own price elasticity of demand when revenue is maximized. Okay, let me do it at this side. So the B, the own price elasticity of demand. If I just make it OPED, or yeah, let me just make it own price elasticity of demand. So for the own price elasticity of demand, we know the formula is del QX over del PX times PX over QX. Yes, the change in QX over the change in the price of X times PX is diagonal, then over QX. Do you get it? But there is a problem. Now, when you get to this side, you might easily be confused. Do you get it? Because you have del QX over del PX. You can easily go to the price function and decide to differentiate like this. But then this one, we are supposed to differentiate with respect to P. Do you get it? Meaning that you have to have the quantity function. You only have the price function. You get the one that's at the top. That's the one that you have. You realize that when we were differentiating this one, it was the total revenue that we were given. You get it? So DTR will come first over DQ, meaning that you're differentiating this one. But this one, you only have the price. So you have to make Q the subject in the price function. You get it? So you already know that our P is equal to 60 minus 0.05 Q. So P is equal to 60 minus 0.05 Q. I hope no one is confused. 60 minus 0.05 Q. All right, so now we have to make Q the subject so that this function will be in terms of Q. You get before we can find for this. So in making Q the subject, I can decide to let negative 0.05 Q come to this side. So 0.05 Q should be equal to 60 minus P. Right, when P crosses the equal sign, and I can decide to divide here by 0.05 and also divide here by 0.05 so that this will cancel this. Then I'll get my quantity to be 60 minus P over 0.05. Now here, please pay attention. Q is equal to, it's supposed to be 60 over 0.05, then minus P over 0.05. The 0.05 is affecting all of them. So let me take it step by step so you don't get confused. So we are having 60 over 0.05, then minus P over 0.05. But when we have P, it's the same as 1P. Do you get it? There's like an inversible one. So let me just put a 1 here so I don't get confused. You get it? So now KO should be equal to 60 over 0.05. That should give us 12,000 when we punch on the calculator. Then negative, there's an invisible 1 attached to the P. If you have X, it's the same as 1X. So negative 1 over 0.05 should give us negative 200, right? Then you add the P. Do you get it? Because there's already P here, so you have to add it to it. All right. So now this would be our quantity function. Let me clean this side so that we can solve the question well. Right. So now we have our quantity to be 12,000 minus 200p. I hope you understand this. We just made Q the subject from here. You get it? The other way is to make Q the subject. So any other way you can do it that you'd arrive at this would be accepted. All right. So now that we've got a quantity find, now we can now find the del QX over del P. Do you get it? So now our del QX over del P then times px over qx. So del qx over del p. So it means we just have to take the coefficient of p. You get it? And we are getting negative 200. Then times px. The question said for the own price elasticity of demand when revenue is maximized. In other words, use the price and the quantity that maximize the revenue. And we already solved for that in A. We got our price to be, what was our price? Our price was 30. What we just solved for right now. Our price was 30 and our quantity was where is it? Yeah, the quantity was 6,000. So that's what you are going to use here. So times px, which is 30, then over the qx, which is 6,000. So when we punch this on the calculator, negative 200 times 30 over 6,000, we should be getting negative 1. But put it in your head, for price elasticity of demand or own price elasticity of demand, we always take the absolute value. Do you get it? So this will be positive 1. Do you get it? And anytime you get your own price elasticity of demand to be 1, it means that it is unitary elastic. Please don't forget these things. They are very important. Do you get it? You're not going to be given any formula for this, so you have to try and chill them. So if you solve for price elasticity of demand and you get positive 1, it is unitary elastic. If you get anything greater than 1, it is elastic. However, if it is less than 1, it is inelastic. Please don't forget these things. So now we know that you are getting 1, which means that it is unitary elastic. And just put it in your head, you can be asked, anytime you get something to be unitary elastic, I mean price elasticity of demand to be unitary elastic, that's when revenue is maximized. So revenue is maximized when own price elasticity of demand is unitary elastic. So don't forget this. All right, so that's for the B, right? Now let's go to the C. The C says that find the output level that maximizes the company's profit. All right, so let me clean the board so that we solve for this one. All right, so the C says that we should find the output level that maximizes the company's profit. So we have to find the profit before we even know the output level that will maximize the company's profit. And put this in your head, profit is total revenue minus total cost. I'm sure everyone knows this by now. So now we know that our profits, who represents profits by pi in this topic, is equal to total revenue minus total cost. So our profit is total revenue. Our total revenue is here, which is 60 kil minus 0.05 kil squared, then minus the total cost. And when you are doing this, I'll advise you to put it in brackets because the negative is affecting everything in the total cost. So minus this, minus this, minus this. So if you don't put it in brackets, you might easily get confused. So please, this part, try and put it in brackets so you don't get confused. So minus the total cost, so into brackets, 8,000 minus 5 kil plus 0.005 kil squared. All right. So now let's simplify. Our profit should be 60 kil minus 0.05 kil squared. Then the negative is affecting all this. So negative 8,000 will give you negative 8,000. Then negative 5 kil will give you positive. Negative is positive. So plus 5 kil. Then negative 0.05 kil squared. Negative positive will give you negative. So negative 0.005 kil squared. All right, so here is supposed to be 60 kil minus 0.005. I just realized here is 0.005. So let me change it here. So 60 kil minus 0.005 kil squared, then minus the total cost. So here to be negative 0.005 kil squared. All right. So yes, so now we found our profit function, which is 60 kil minus 0.005 kil squared minus 8,000 plus 5 kil minus 0.005 kil squared. But then there are still some like terms, so we can simplify. So 60 kil and 5 kil are like terms. So 60 plus 5 should give us 65 kil. Then negative 0.005 kil squared minus 0.005 kil squared should give us negative 0.01 kil squared, right? Negative 0.01 kil squared. Then negative 8,000, there's no other number, right? So minus 8,000, right? This should give us our final answer or our final profit function. So our profit function is 65 kil minus 0.01 kil squared minus 8,000. All right, so now that we know our profit function, we are asked for the output level that will maximize the company's profit. So I tell you that anytime you are given a function or you have a function and you want to know the maximum or even the minimum, you have to differentiate and equate it to 0. So we're going to differentiate this function. So we have the pi over the kil. You get it? Or del pi over the kil. Let me make it. All right, sure. So now we are differentiating 65 kil with respect to kil. So we get 65. The kil will vanish. Then negative 0.01 kil squared. You are differentiating it. So 2 multiply negative 0.01. And that should give us 0.02, right? Then minus 8,000. That one will give you 0. If you have a number, the whole thing is 0. So you don't add anything. So now, so here, I forgot the Q, so negative 0.02 Q, right? The 2 would reduce by 1, but it's the same as exponent 1. So, yeah, so now that we've differentiated the profit function, we are going to equate it to 0, right? So we are going to get 65 is equal to negative 0.02 Q. When it crosses the equal to sign, it becomes positive. So it's equals positive 0.02 Q. Then you are going to divide both sides by 0.02, divide here by 0.02 as well. So this will cancel this. So our Q will be equal to 65 over 0.02, and that should give us 3250 units, right? So this is the quantity that, or the output level that maximizes the company's profits. 3,250 units. All right, so now let's move on to the D. So the D says that at what price is maximum profit achieved? So now we already know the quantity or the output level, but now we have to substitute it into the price. You get it? And I think when we were doing for the B or so, or the A, we said that the price was equal to 60 minus 0.005 Q. If I recall, I'm sure you guys were writing, so you remember this. You get it? All right, so now we got the P to be 60 minus 0.005 Q. That's what we solved earlier on. So now if we have our P to be 60 minus 0.005 Q, we just substitute the Q, which is 3250, into it. Then we get a price that will maximize the company's profit. So our P will be equal to 60 minus 0.005 times 3250. So when we punch all this on the calculator, 60 minus 0.005 times 3250, we should be getting 43.75. So 43.75. You see this, right? So yes. So the price that will maximize the firm's or the company's profit is 43.75 cedis. All right, so that's for the D. Is that the last one? Okay, there's an E as well. So the E says that we should determine how elastic demand is at the profit maximizing output level. I don't even need to clean the board since the solution is not long. So let me just do it somewhere here. So that's for our E. So we asked for the how elastic demand is at the profit maximizing output level. These are the profit maximizing output level, this and this. That's when we got the price and the quantity that maximize the firm's profits. First 0.75 and 35. So we'll substitute it into the elasticity formula. And we said the formula for the elasticity of demand is del Qx over del the price times P over Qx. That's the same thing we did in B, right? So now the del Qx over the del P is negative 200. We did this earlier on. I hope you've not forgotten. Please, if you've forgotten, please try and go back to the B. We solved that one there, but then I claimed it because of space. But then since you have the book, I'm sure you remember that. So when we got the del Qx over del P will be the same thing, which is the negative 200 we solved for earlier. Then times the P. They said the profits maximizing output, right there. How elastic demand is at the profits maximizing output level. So you are going to substitute the price and the quantity that maximize the profit. So the price is 43.75. So times 43.75 over the quantity QX, and that was 3250. So now we can solve for it. Negative 200 times 43.75 over 3250 should give us 2.69 or negative 2.69. But we only take the absolute, which is 2.69. You get it, or the positive value. And since 2.69 is greater than 1, we say that it is elastic. You get it. So if it's greater than 1, we just say it's elastic. All right, so we are done with the E. So yes, that's for question 2. In the next video, we are going to look at question 3. Thank you for watching this video, and I'll see you in the next video.